Namaste and a very good evening to all of you. I welcome you to my channel, The Outliers. My name is Mithun. In today's video, I'll be talking about a very interesting machine learning algorithm called as the random forest. Even before I proceed to demonstrate how to perform a random forest model using STATCRAFT, may I request you to subscribe to my channel, also like and share my videos. Let's begin by asking a simple question. What exactly is a random forest? Random forest is a commonly used machine learning model which has been trademarked by Leo Breiman and Adil Cutler. It combines the results of multiple decision trees to reach a single result. Secondly, random forest is a supervised machine learning model. Thirdly, random forest belongs to a class of techniques which can handle both classification as well as regression type of problems. Fourthly, random forest is part of a wide variety of techniques which are called as ensemble methods. Ensemble learning methods are made up of a set of classifiers, not one classifier, but a set of classifiers, example decision trees, and their predictions are aggregated to identify the most popular result. What happens in a typical random forest is that it's not one decision tree that we are building. We are building multiple decision trees, and then we aggregate the results of the decision tree. By combining the results of a decision tree, we can then build one final model. Decision tree is not an ensemble technique. Random forest is an example of an ensemble technique. What are the benefits of a random forest model? Typically, a random forest model reduces the risk of overfitting. This is a very important point. When you build a model like decision tree, you may obtain a high accuracy, but typically decision tree models suffer from a problem known as overfitting. Unlike the decision tree models, random forest models reduce the risk of overfitting. So this is one great advantage when you build a random forest model. It attacks the problem of overfitting. Secondly, random forest provides flexibility. Thirdly, random forest is easy to determine the feature importance of variables. What are the key challenges of building a random forest model? First, it is a time-consuming process. Second, it requires more resources. And thirdly, it is more complex than a typical tree-based model. Now, let's talk about some of the application areas for random forest. There are three application areas for random forest. This is only indicative but not exhaustive. Firstly, random forest is widely used in finance. This is because it reduces the time spent on data management and pre-processing tasks. It can be used to evaluate customers with high credit risk. Random forest can also be used for fraud detection and option pricing problems. Secondly, random forest is also used in the field of healthcare. Applications in computational biology, especially in areas like gene expression classification, biomarker discovery, and sequence annotation. These are some of the applications of random forest in the field of healthcare. Finally, it's also widely used in e-commerce space. Here, random forest can be used for recommendation engine to build a recommendation engine for cross-selling purpose. So these are the three main application areas of random forest. Now, let me introduce you to the data set that I'll be working on. This is a very popular data set which is called as the iris data set. I've used it in some of the other videos as well. I use this data set because it's a lot easier to work with and explain a lot of the concepts surrounding any algorithm. In this data set, there are 6 different fields. The first field is the flower ID. Then we have different flower characteristics. You can have variables like sepal length, sepal width, You also have petal length and petal width. The last variable is the species of the flower. I will be using species as the target variable. The rest of the variables from sepal length all the way up to petal width will be used as independent variables when we build a random forest model. We are interested in identifying the feature importance. Out of these four variables, namely sepal length, petal width, which field is the most important field which can be used to classify the species of flower? What is the sample size in this data set? If I go to the last row, you can see there are 150 records, which means that the sample size in this data set is 150. Further, let me apply a filter here in Excel. Now, after applying the filter, let me show you some of the classes that are present in the target variable, namely species. There are three types of flower: setosa, versicolor, and virginica. As you can see here, our target variable has three different types of flowers. So which means this is a multi-class problem. This is not a binary class problem. This is a multi-class problem having more than two categories. With this introduction into the data set, I will now proceed to demonstrate how to build a random forest model using a software called as STATCRAFT P. As you can see here, this is the interface of a software which is called as STATCRAFT P. This is a Make in India initiative. I've already loaded the source data set into this particular software. As you can see here, these are the 6 variables that we have in the data set. ID variable is not very useful for building any machine learning model. I will primarily be using sepal length, sepal width, petal length, and petal width as the input variables and the variable species as the target variable. Now, how do we navigate step by step and build a random forest model to classify the flower into one of the species depending upon its characteristics? To do this, at the left-hand side top corner, you have what is called as the analysis button. The moment I click on the analysis button, you can see here, STATCRAFT displays the different options that are present. Let me choose the option Machine Learning. I will click on the drop-down menu. In the drop-down menu, you have different options for machine learning model. Let me scroll down further here. Here, you can see Random Forest Classifier. There are two different features. The first one is Random Forest Classifier. Below this, you can see Random Forest Regressor. You can go ahead and use the Random Forest Regressor when the dependent variable is numeric or scale. In my case, in the case of iris dataset, the dependent variable is a categorical variable. Hence, we will be using Random Forest Classifier. Let me press refresh. This is the dialog box for the Random Forest Classifier. In the left-hand side, you can see all the fields that were present in the data set. And the right-hand side, you can see the dependent variable field. You can also specify the independent variables in the space allocated for independent variables. Let me begin by specifying the dependent variable. What is the dependent variable here? It is species. Which are the independent variables here? Sepal length, sepal width, petal length, and petal width. These are the 4 independent variables that I have. If you want to provide your own parameters for the model, you can choose the option parameters. There are different options here. By default, the Random Forest Classifier will build 100 trees at the back end. Remember, this will build 100 trees, and then we are going to combine the results of these 100 trees and give you one final model. You can see here there are different parameters of the model which we can experiment with. Right now, I want to keep it very, very simple. So I'm not going to change any of the parameters here. Let me draw your attention also to the training size. It is 75%, which simply means that out of 150 records, 75% will be used to train the model. The remaining 25% will be used to test the model. Further, you have what is called as the options tab. Here, under the criteria section, you have the Guinness method. You can also choose the entropy-based model. At the back end, you have two options under bootstrap. If you choose true, bootstrapping method will be used. Else you can choose the option false. Under warm start, you have either false and true. I will use the default options. If the random forest model gives me poor results, then I will come here and experiment with the different hyperparameters. Finally, you have the option for save. Here there are three different items. Either you can save the model. If you want, you can save the predicted values and predicted probabilities. What does this do? When you select predicted values and predicted probabilities, two additional columns will be created in the data set. The first one, which indicates the predicted value of the flower, whether the first record, let's say, is setosa or versicolor or virginica, that will be indicated. Secondly, STATCRAFT will also quote the predicted probability with which we are saying whether the first flower is setosa or versicolor or virginica. Once you have made these selections, when we come back to data and inspect whether everything is selected properly, now I can go ahead and hit the OK button. This will run the random forest classifier. We will be running 100 decision trees and aggregating the results. You can see here the output has come in a jiffy, which means that STATCRAFT P is quite fast in processing very, very complex analysis. What you're seeing here is the output for the random forest classifier. Very interestingly, STATCRAFT P has given you the Python code. This is very, very useful because you can copy this particular Python code and paste it in Jupyter Notebook and run the analysis for any advanced level of calculation. The entire Python code is available, which STATCRAFT has used at the backend to run the random forest model. Now, let me scroll down further. This table is very, very important. This table is very, very important. You can see here, it says feature importance. There are two columns here. The first column is variable, and the second column is the importance of that variable in classifying a species of flower as setosa, versicolor, or virginica. What you see right at the top is petal width. And look at its importance, 0.46, which means 46% weightage or importance is given to the variable petal width in classifying the flower as either setosa, versicolor, or virginica. So petal width is one of the most important variables in classifying the flower species. Next, let me take a look at petal length. This variable has an importance value of 43%, very close to petal width, but slightly lesser than petal width. The importance of petal length is 43%. So 46% is the importance of petal width, 43% is the importance of petal length. If you combine these two variables, roughly you can say around 89%, or if I round it off, approximately 90% of the importance is for the petal characteristics. So petal width has a weightage of 46%, petal length has the next important weightage of 43%. Please look at sepal length and sepal width. Its importance is very low, merely 8% and 2%. So 90% of the importance is given to petal width and petal length in classifying the flower species as either setosa or versicolor or virginica. So petal characteristics are playing a more important role as per the random forest model that we have built as compared to the sepal characteristics. Further, if I scroll down, you can see the confusion matrix. Now this tells me the performance of the model. Is the model performance good or is it bad? Now this is very easy to interpret. Let's pay attention to the confusion matrix. You can see here, this is the confusion matrix for the training data set. In the row, we have three classes, setosa, versicolor, and virginica. This is the actual class. And in the column, we have the predicted class, predicted by the model, predicted as setosa, versicolor, and virginica. How do we interpret the confusion matrix? A simple thumb rule is to look at the diagonal elements. Why do I say look at the diagonal elements? Simply because the diagonal elements represent the correct classification, while the off-diagonal elements represent the incorrect classification or the misclassification. Let me look at the setosa flowers. 34 out of 34 setosa flowers have been correctly predicted as setosa. So you can say that when it comes to setosa flowers, we have a model whose accuracy is 100%. So if you give a setosa flower characteristics, the random forest model is able to achieve 100% accuracy in classifying setosa as setosa. Now let's look at versicolor. The row is versicolor, the column is also versicolor. So 42 versicolor flowers have been correctly predicted as versicolor flowers. And lastly, we have the number 36. 36 virginica flowers have been correctly predicted as virginica flowers. So 100% accuracy we are able to obtain in the training data set. Now I know that this is a very small data set and therefore we may be getting 100% accuracy, but for a real-time data set, it may not be 100%. It will be a lot lesser than this. Also, the performance of a model is not assessed by looking at the training data set. We assess the performance of the model by looking at the test data set. Let's look at the performance of the random forest classifier using the test data set. As you can see here, the diagonal elements, 16 out of 16 setosa flowers have been correctly classified. So there is 100% accuracy when it comes to classifying setosa flowers. Now let's look at versicolor. Again, 8 versicolor flowers have been correctly classified as versicolor. When it comes to virginica flowers, 11 virginica flowers have been correctly classified, whereas 3 of them have been misclassified. So this is how you can assess the performance of the model. If you want an overall classification report, you can see here, this is the classification report table. In this table, you have a lot of important metrics like precision, recall, and F1 score. Let's look at the first species of flower, namely virginica. The precision is 1, the recall is 1, as well as the F1 score is 1 here. Any number, for example, if the precision value is greater than 0.7, or if the recall value is greater than 0.7, for that matter, even your F1 score, if it is greater than 0.7, you can go ahead and say that such a model is a good model. What is precision? Precision is simply the ratio of true positives divided by true positives plus false positives. Precision shares a very important relationship with the false positives. If the false positives increase, precision goes down. If the false positives decline, precision goes up. So there's an inverse relationship between precision and false positives. Because the precision value is 1, it means that the false positives is 0. Now, when you talk about recall, recall again has a very interesting relationship with false negatives. What is recall? It is simply the ratio of true positives divided by true positives plus false negatives. False negatives is in the denominator So recall shares an inverse relationship with false negatives. If recall goes up, false negatives go down, and vice versa. You look at the performance of the model in classifying setosa flowers. Again, it is 100%. And for versicolor flowers as well, we are getting 100% for precision, recall, as well as the F1 score. This is for the training data set. If we scroll down, now let's look at the performance of the model for the testing data set. When you look at Virginica, the precision is 1. The recall here is 78%, and the F1 score is 0.88. F1 score is simply the harmonic mean of precision and recall. 2 times precision multiplied by recall divided by precision plus recall would give me the F1 score. When you look at setosa, the precision value is very high of 1. Recall is also very high, it's 1, and the F1 score is 1. Now let's pay attention to versicolor. The precision is above 70%, recall is 100%, and the F1 score here is 0.84. What can we conclude when you look at this model? The performance of the model is satisfactory on the test data set. It is quite good on the training data set. So we've looked at the confusion matrix. We've also looked at the classification report. Further, we have looked at the feature importance table. The last thing that I'd like to show is the predicted probabilities. For this, I can just click on the view button as I have done now. Let me just click on this once again and choose the data button. You can see here, we had 6 variables initially. Now we have 2 additional columns. That is the predicted value and the predicted probability. The first flower, you can see here, has been predicted as setosa flower. Its actual category is setosa. It has been predicted as setosa. When the actual and the predicted match, it is the right classification. Further, when you look at probability _1, this indicates the probability with which we are able to classify the first flower as setosa. Because it is 1, we can say that the random forest classifier is 100% confident that the first flower is a setosa flower. Our model, it looks like, has understood the pattern or the characteristics of setosa flower. Please take a look at the actual category and compare it with the predicted class. They are matching, which indicates that when it comes to setosa, the actual is matching the predicted, and therefore almost all the setosa flowers have been correctly classified. Further, you can see here the performance of the versicolor, performance of the random forest model in classifying the versicolor flower species. I'm just picking up a random case here. This is a versicolor species of flower. This has been predicted as versicolor with 100%. If you look at the earlier case, this is versicolor. This has been predicted as versicolor with 82% confidence. Let me look at the second page. Here you can see the actual class being Virginica and the predicted values for the model. The second case is very interesting. Here you can see the actual class is Virginica. It is predicted as Virginica with 99% probability, which is on the higher side. With this, I have come to the end of today's video. I thank you very much for watching this particular video. I'd like to give you a very high-level summary of what we have done. We have seen what exactly is a random forest model. It's a classification algorithm which involves building multiple decision trees and then combining these multiple trees to get a more accurate result as compared to one single tree. Secondly, what are the advantages of building a random forest? The main advantage of building a random forest is that it prevents overfitting by using multiple trees. Secondly, it is highly accurate and precise. Thirdly, random forest can handle noisy data. Now, let's talk about the disadvantages of building a random forest model. One of the main disadvantages is that because we are building multiple decision trees, this is a time-consuming process. Secondly, because we are building multiple decision trees and aggregating the results, this is resource intensive. Lastly, the output of a random forest model is less interpretable as compared to a decision tree model. With this, I have come to the end of today's video. I thank you very much for watching this video. I request you to subscribe to my channel, also like and share my videos. Thank you very much for watching this particular video. Have a great day ahead.